Okay, so this is the key to section 1.6, part 2, and in this case you're dealing with radical equations, and so these are going to be square roots, so in particular, so these are square root radical equations. Now, I'm going to go ahead and just go ahead and transpose these sides. So x equals square root of 3x plus 10 is the same thing as saying square root of 3x plus 10 equal x. It doesn't matter, you can leave it like this if you want to. Now I'm going to go ahead and remember the square root is by itself, so remember you got to get the square root by itself. So it is by itself. Um, we're going to go ahead directly and raise both sides. Remember the step is to raise both sides to a power that's equal to this index. So since we're dealing with square root, the index is 2. So I'm going to square both sides, just like this. And I'm going to get the square and the square root into each other, so you get 3x plus 10 equal and then x squared. So notice I went from a radical equation to a quadratic equation. And to solve this quadratic equation, we're going to put it in standard form, so we're going to bring all the terms to one side. So I'm going to get, so I have to subtract 3x, combine like terms, so I get 10 equal x squared minus 3x. Then the next thing I'm going to do is subtract 10. So remember what you do to one side, you do the other. Do one thing at a time so you don't mess up. 10 minus 10 is 0. You got to put a 0 there. Equal, and then you get x squared minus 3x minus 10. Alright, now we got to solve this quadratic equation. So I'm going to just go ahead and transfer. I should have left this as this because I realized that now I'm going to go ahead and transpose both sides. So I should have just left it like that, but it's okay. So I'm going to x squared minus 3x minus 10 equals 0. Alright, now we're going to factor this. If it's not factorable, remember you have to use the quadratic formula. I would not use completing the square here because then you're going to end up with fractions. So just use quadratic formula. If you don't remember how to factor this, but let's see if we can factor this. This should be factorable. So x times x is x squared. The possibilities for 10 are 5 and 2, 10 and 1. Now remember, the last sign is negative. That means one of these is negative, one of these is positive. And the outer and the inner, when added together, ought to be should give you negative 3x. So let's put the 5 here, the 2 there. And let's think about this. The outer is 2x, the inner is 5x. And remember, one of these has to be positive, one of these has to be negative, because that's the only way you can get a negative 10. A positive times a negative is a negative. The larger of these, 5 and 2, will take this middle sign. So that means that 5x has to be negative and 2x has to be positive. And notice when you add them up, negative 5x and positive 2x is a negative 3x. So that means that this has to be x minus 5 and this has to be x plus 2. Alright, now I set each one of these equals 0, so using the zero factor property. And so when I set each one equal to 0, I get x minus 5 equals 0, x plus 2 equals 0. And then notice you went from a radical equation to a quadratic equation to 2 linear equations. And so you add 5 to both sides, you get x equal 5. You subtract 2 from both sides, and you get x equal negative 2. Now, remember this. When you raise both sides of an equation to an even power, you have to check your solution. Okay, so you must check your solutions, if you raise both sides to a power, to an even power, to raise both sides to an even power. Okay? Alright, and I did here. I did that right here. So I raised both sides to even power. So basically what you're doing is you're checking for extraneous solutions. That's what you're doing. So basically false solutions, false roots. And we'll see what that means. Okay, so basically, and remember, you have to go back to the original equation. So you must check the original. So let's see, go ahead and do here. So check x equals square root of 3x plus 10. So let's check x equals 5. So I go back and wherever we see a 5, wherever we see an x, I plug in a 5. So I get 5 equal square root of 3 times 5 plus 10. 3 times 5 is 15. So again, I'm checking to see if that's true. And 15 plus 10 is the square root of 25, and square root of 25 is 5. So that works, so 5 works. So overall my solution is 5. And let's check negative 2. I'm going to go ahead and do that here. Let's check negative 2. So again, you go back to the original. X equal the square root of 3x plus 10. So I'm asking, is negative 2 equal to the square root of 3 times negative 2 plus 10? 3 times negative 2 is a negative 6. Negative 6 plus 10 is 4, and the square root of 4 is 2. So is a negative 2 equal to a 2? And the answer is no. Those are not equal. Now, so what that means is that x equal negative 2, this right here, is an extraneous root. So it's a false root. Now, it's a solution. This right here, negative 2, is a solution. It's a solution to this quadratic equation because that's how you factored it. So if you plug in negative 2, look at this. Negative 2 squared is 4. Negative 3 times negative 2 is a positive 6. So 4 plus 6 is 10. 10 minus 10 is 0, so it does equal 0. But the problem is it's not a solution to the original. So that's why it's an extraneous root. So it's a false solution. So it satisfies this equation, but not the original. So the only solution is this. Alright, so again, when you raise both sides to even power, you must check your solutions. Check for extraneous solutions. Look at the next one. So here I'm going to, again, the square root's by itself, so you're going to square both sides. Square both sides. And then the square and the square root into each other, so this is x plus 5. Cool. Alright, now here you're going to have to FOIL this out. So you have to say x minus 1 times x minus 1. So FOIL, same FOIL. X times x is x squared. The outer's a negative x. The inner's a negative x. Now remember, if the binomials are the same, the outer and the inner should be the same. So always remember that. And then negative 1 times a negative 1 is a positive 1. Combining like terms, I get x squared minus 2x plus 1. So that goes here. So x squared minus 2x plus 1. And then remember, you got to bring all the terms to one side. So I'm going to subtract x from both sides. Combine like terms. Notice I'm aligning my like terms. This is 0, so I'm going to put 5 equals x squared. And negative 2x and negative x is negative 3x plus 1. Subtracting 5 from both sides, I get 0 equal x squared minus 3x. A positive 1 and negative 5 is a negative 4. Alright, and again, let's factor this. I get 0 equal. Now when you factor this, that's going to be x minus 4 times x plus 1. And again, always check your work. Remember, this is negative right here. The last sign is negative, so 1 is positive, 1 is negative. Alright, so x times x is x squared. Negative 4 times positive 1 is negative 4, but we got to check this negative 3x. So the outer is a positive 1x, the inner is a negative 4x. When I add them up, I do get negative 3x. I'm going to use the zero factor property, so I'm going to set each one of these equals 0. So x minus 4 equals 0, x plus 1 equals 0. And notice I went from a quadratic equation to a radical equation to a quadratic equation, which I solved by factoring, and then to two linear equations. So here x equals 4, and here x equals negative 1. Now don't make a mistake and say those are your solutions, because remember, you raise both sides to an even power, so you have to check for extraneous roots. So all you do is go back to the original. You have to go back to the original, so you must check for extraneous roots. Alright, so go back to the original. So that's square root of x plus 5 equal x minus 1. So let's check x equals 4. So where we see an x, I plug in 4. So I get the square root of 4 plus 5 equal 4 minus 1. So I'm just seeing if that's true. 4 plus 5 is 9. And the square root of 9 is 3. 4 minus 1 is 3. And it does check off. So for I can say x equals 4 is a solution. Now let's check x equals negative 1. Okay, let's go back to the original. So I'm checking x equals negative 1. You must check for extraneous roots when you raise both sides to even power. You have no choice. Alright, so negative 1 plus 5. So where we see an x, I plug in negative 1 equal, and I'm asking, is that equal to negative 1 minus 1? Well, negative 1 plus 5 is 4. Square root of 4 is 2. Negative 1 and negative 1 is a negative 2. Those do not equal. So what that means is that this right here is an extraneous root. Now what that means, again, just like the previous one, is that it satisfies this equation, this quadratic equation right here. Right, because that's how we got the solution. So it does satisfy the quadratic, but it doesn't satisfy the radical. So if you look at the negative 1 times itself is 1, negative 3 times negative 1 is a positive 3, 1 and a positive 3 is a positive 4, 4 minus 4 is 0. But again, we just saw that negative 1 does not work. Alright, so it's extraneous. So the only solution is this. Alright, so that's going to take care of section 1.6, part 2.